Good day, learners. This is Easy Engineering. This time we're going to talk about vector addition component method. In this video, we're going to learn how to add vectors using component method. This kind of method is the commonly used method in solving complicated problems involving vectors. Let us begin by resolving the x component and y component of this vector. A 5 Newton force is applied to the box at an angle 30 degrees counterclockwise from the positive x-axis. The question is, what is the x and y component of this force? Let's view this force as a right triangle. We just need to get the value of x and y, and that will be the x component and y component of the force 5 Newton. To get the value, we use SOHCAHTOA. We just need to use the sine and cosine theta and make use of the angle 30 degrees to get y and x respectively. Plugging in known values now we have the x component, which is equal to 4.33 Newton, and y component, which is 2.5 Newton of forces. They are all positive because they lie on the positive x and y axis. Next, what if we have two vectors and we are asked to get the resultant vector? We just need to add the x and y component and get the resultant magnitude and direction. For example, suppose you applied a 5 Newton force on the box at an angle 30 degrees counterclockwise from the positive x-axis, and your sister applied also a 7 Newton force on the box at an angle 60 degrees clockwise from the negative x-axis. What will be the resultant force and at what direction? To solve this, we need to resolve the x and y component of both vectors. From the previous example, we have the x and y component of vector 5 Newton at 30 degrees counterclockwise from positive axis. These are x component 4.33 Newton and y component 2.5 Newton of forces. We need the other vector, and let's view this as a right triangle. We need to use again the SOHCAHTOA, and now we have the x component, which is equal to negative 3.5 Newton, and y component of 6.606 Newton of forces. Take note that it is negative on the x component because it lies on the negative x-axis, while positive on the y component because it lies on the positive y-axis. Then let's add all the x component and y component. Here we have summation along x component is equal to 0.83 Newton, and summation along y component is equal to 8.56 Newton. Since the value of resultant x component is positive and resultant y component is positive, we can say that the resultant vector force is on the first quadrant. We can view this as a right triangle. To get the resultant vector force, we use the Pythagorean theorem. So we have c squared is equal to a squared plus b squared. So the magnitude of resultant vector force is 8.16 Newton. Then we need to find the angle. Let's view it again as a triangle. Then we use again SOHCAHTOA to find the angle. This time let us use tangent. So the direction is 84.46 degrees counterclockwise from the positive x-axis. To sum up, the resultant vector force is 8.16 Newton at 84.46 degrees counterclockwise from the positive x-axis. Before we end, let me leave you with the steps on solving the resultant vector given multiple vectors. 1. Get the x and y component of each vectors. 2. Get the summation of x component and y component. 3. Use the Pythagorean theorem to get the resultant magnitude. And 4. Use inverse tangent function to get the direction.